Okay, okay, guys. So, in continuation to what we're doing, we have two ways in which assembly questions in assembly drawings will come. As I said, there are ways in which we can be able to learn how to assemble parts. There are some clues that can help us to be able to study the parts and know where which part will go and where which part will fit and where which part will mate. And after following those clues, would have a perfect assembly. So, how do we do that? Now, there are several ways in which we can be able to assemble a part, several clues to how we can be able to assemble a part. Now, the first method is features. So when we say features, we are looking at the threads, internal or external. So threads, um, that is into brackets, internal and external thread. You already know what a thread is. It could be a hole, could be round, square, etc. Um, we could also have a slot, a protrusion, extrusion, intrusion. So any of these features. So if it's a thread, that means that let's say you have an internal thread and you have an external thread. Same thread classifications, right? Same thread classifications. Then it means that one part of the thread will fit into another part. An external thread will fit into an internal thread. If it is a hole, you have a round hole, you have a square hole, the sizes of the hole is the same as a protrusion, then it means that it will also fit in there. So if you have an example, let me call up the paint. So if your example you have a hole which is in a material. Let's see if I can increase the thickness of my line. So let me redraw this match taker. Let's say this is a rectangular hole in a component, and you have an extrusion like this. An extrusion is just a deformation like this. The parts dimensions are the same as the dimensions are here, same dimensions for the hole. Then it means that this can fit right into this. So that gives you an idea that there is assembly between these two, right? If trying to end the command. Now, if we also should have some extrusions or for yes, some extrusions where let's say we have this part and then we have a member here. We also have one here. Then you also have another part. Also another member here. This part can flip and fit right in between this. Right, so this can also give us an example or can also give us a clue as to how we assemble. So features, external features, internal features, slot protrusions and holes can give us an idea how we can be able to assemble a product. The second one is dimensions. So if you have dimensions on a part, based on the dimensions, you can be able to tell where if other parts, if it can be able to merge with other parts. You have a hole and the hole has a diameter of 30, and you also have an object same size as the hole or same shape as the hole, same diameter. You know that the two parts will fit. So diameters can also be able to help us a lot to determine how we can be able to assemble a part. Then the third one is the geometry. So the shape and size of a part can be able to tell us how we can be able to assemble those parts. Example, in a situation whereby you have a part that looks like this, better. You have a part that looks like this. You also have another part which looks like this. The dimensions for this part corresponds to the dimensions to this part. Then you know that this part will fit into this part and the two will assemble. So that is geometry. So based on the geometry of the part, we can even have something like this. You can also have another part like this. And based on the geometry, you realize that this part fits properly and closely into this part. Based on the dimensions and the geometry, it can give you a clue that these two parts can be able to assemble together, or these parts can be assembled together. So that is also another clue. So in looking at geometry, those are the things that we consider. Then we have the last one, which is function. So function depends on the functionality of the part. If you are given the part and you are told the function, or let's say you are told that okay, these are the parts of a water pump, and you are to assemble them, then you've been given a clue or you've been given an idea of what you are to assemble. If you know the function of that machine, it makes it easier for you to know how to assemble it. Because you know for a water pump, you have a blade, there'll be a blade, there'll be a hub, there will be a shaft that will be inside this blade that will connect this blade to a system. There's going to be a case, there's going to be an inlet, there's going to be an outlet. There's going to be a case, there's going to be how do I put it? A cover, a blade, a shaft. And you already would have an idea as to how the assembly would be. So if you know the functionality of the pump, you know how the pump works, that will make it easy for you to be able to assemble the parts. So the functionality of the product too also helps you to understand how the parts come together and how we can be able to assemble it. Now, exercises for um, assembly drawings can come in two forms. We can have 3D illustrations like this, and then you have to figure out how to assemble the parts together. Or you can also have an orthographic view of the parts for you to be able to assemble them together. So let's look at the 3D isometric representations and how you can be able to assemble the parts together. So a minute, let me quickly do. All right, so this is a drill pump, right? And we are to prepare the assembly drawing and the bill of materials on the same sheet. Use a multi-view projection for view layout. Now, we have been given parts of the assembly. We've been given the parts of the assembly. And this is just to help us to be able to assemble the parts. So when you look closely at this, you have the casing, you have the ring, you have the seal, you have the um, plastic bushing, you have your shaft, you have your paddle wheel, you have your cover, and then you have your bolts that fit in there. Not all the parts are shown here, but this gives you a fair idea of the general assembly. So how can we be able to tell that this is how it's going to go? Let's first look at the let's first look at the casing. So you realize that the casing has an internal structure mostly made of holes, right? A lot of holes in it. Let's look at the diameters of the holes. We have 0.233, that is for this part, right? We also have 0.6, which is for this part to here, from here to here. We also have 1.06, which is okay for this diameter, and then we also have for this structure. So that means that this part, um let me see if we have the dimensions here. So this part will be slightly over 1.06. We also have another diameter here, which is 2.062. We also have this overall diameter, which is 2.828, right? So from here to here is 2.828. Now, this diameters or these holes should be give us a clue as to which part will fit, because we know they are circular, they are cylindrical, and they have diameters, so all parts should follow that same sequence. So let's come to the shaft, right? So when you look at the shaft part 5, the shaft the shaft has a diameter of 0.233. So when we look at this diameter, this is 0.233. When you fit 0.233 here, you will fit right into this, right? So diameter. Then when we come to the paddle wheel, the paddle wheel also have 0.23 here. So that tells you that this will fit right into this here, and it has a general diameter of 1.9, right? This 1.9. The 1.9 also fits in here, and since 1.9 fits in here, so it will be in here. This one will also be in here. Then let's look at when we come to the cover, let's look at the seal. So we have the seal here, which has a general diameter of 0.58. So 0.58 and 0.6 is not that different. It's just a matter of zero point 0.2 difference. So this part will fit right into this part. That's the seal. So now when the seal sits, you're also going to have the bushing. Also going to have the bushing. And the bushing too will sit right in the between 0.6 and then 1.0, somewhere in here. Then from there, our cover, which has a total diameter of 2.828, this is its cover, would also be placed on this part and then fastened, because this part from here to here also has a diameter of 2.828. So this part would be covered by this part to this, and then you have the hole through this where our screw will be connected to tighten the pump cover to the pump structure itself. So when you look at this, this completely tells you or gives you an idea as to how you can be able to assemble the parts. When you look at this, you see how they all come together. This we didn't see the parts for the O-ring, but it's there. So you have the shaft, the seal, and then the bushing, and then the paddle wheel, and then the cover all into it. So that is how we can be able to determine the look at the assembly of the parts and see how they fit together. Let me also quickly give you a second illustration. So with this illustration, we also have um, a C clamp. Now you can tell the number of parts that we have. We have this as the pin, one part, this has the bodies, another part, this has the swivel, another part, and this as the screw, another part. So the body is one part, part two. We can fit the screw into the body. Now when you look at this, we have the M10 times 1.5. This is M10 times 1.5, the screw. Okay, the external and then the internal screw. Then we also have the swivel, which is 0.9, the hole. And then we also have the base diameter, which is 19. And then we also have for those parts the diameters here, which is 0.625, and then 6.25. And then we also have for the hole here, the hole for this, which is 4.9 and then 4.8. So let's look at the assembly. Let's look at the holes. You know this thread has the same classification M10 1.5 as this M10 1.5. So this screw will fit right into this, right? And then when you look at the diameter for this part, which is 4.9, diameter 4.8, 4.9, this is diameter 4.8, 4.9. This would also fit right into this, right? This fits into this fits into this. Then when you also look at this base, the swivel, this is 0.65. The swivel diameter, when you look at the base, beneath the base, is 6.35. This is 6.25. So that means that this will fit right onto this. When you look at the length, this part will sit right into this part here. It will not go across. It would just get to this point. Let me see. Diameter, right? So it will go through to the base. So this one over here will fit underneath this, and this will be here, and then this will also be here. So going to have an assembly like this. So through, that is this part, through this part, because of the diameters being similar. External thread, this threaded part, which is an external being pushed into the internal part there. And then you also have the swivel where the diameter of this part fits into the diameter of this. So the diameters and the shape of the internal features and the internal features themselves gives us an idea as to how we can be able to assemble the parts. So let's move on to situations whereby you also have the orthographic views. So for this part, we also have an orthographic view, and we have into orthographic projections of the various parts. So this is a knuckle joint. It says this is a pin joint and is used to connect two circular rods subjected to axial loads. Now compared to a socket and spigot joint, wherein the axis of both rods should be in the same plane, in the knuckle joint, oh let's look at this first. Sorry, jumped over. Universal joint. So this is a rigid coupling and is used to connect two shafts whose axes intersect if extended. Now, figure 1 shows the details of universal coupling, and the fork, which is figure 2, are mounted at the ends of the two shafts, right? So we have a description of the various parts. Now, based on the parts list, we have generally 6 parts. And for every part here, we have part 2. Now, part 2, we have 2 projections, a front view, and a plan. For part 3, we also have a front view, a sectioned front view, and a plan. This is also a sectioned front view and a plan. For part 5, we just have a sectioned front view. For part 4, we just have a front view, not sectioned. Of course, we can't section a fastener. Then we have for the shafts also a front view and an end view. And then for the key also a front view and an end view. So the parts have been labeled 1, 2, 3 all the way to 6. We have to look at it. We have to look at them carefully and see how we can be able to assemble the parts. So now let's look at this one. We have for the front view of this part 56. We have a hole here. When we look at the plan of this part, we realize that the hole diameter is 16 for this part. The hole diameter is 16. We also know that the hole diameter here is 30. We also know that the space here, the internal space here is 56. So which part do we have the same 56? Right, we have this part which is 56. We also have the hole here which is having a diameter of 16. So that means that this will fit right into this part, as we can see. Right, so we are going to have this part fit in right here. My lines are not that straight. Let me see. if I can do better with my sketch. So yes, so it fits right in there. Right, so sectioned, that is this part. Let us then add the circular part here. So oh, 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 right, so let's add the circular part. Okay, so that is this fitting right into this, the same hole. What else can we fit? Right, so this one has a diameter of 16 here. This fastener has an external diameter of 16. This also has an internal diameter of 16. So this part looks like a part that can fit into this based on its length. If we add 16 to 16 plus 56, we should have um, about this plus this give us 32. So this will give us 8, and then that will give us 8, so 88, right? So if we subtract 88 from 100, we should be left with 12, right? So we will fit this into this, and when we fit, we are going to get something like this. Right, and then we can also fit, as we fit this onto this, we'll be left with 12, a length of 12 exposed, and this also has a length of 12 based on our calculation. So that means this part here, which is the part 5, the collar, will come and sit right on this, right? And there is a hole here. So this part moves right into this part, and then we also have the diameter of the shaft here, which is 30, and a keyway. We also have a keyway here, so this shaft would move into this part, and the keyway here, the key will fit right into this keyway. So the shaft in here, the keyway in here. So that is how we are going to get the assembly. Now, since from the assembly we are saying that the shaft is 2 and the fork is 2, the pin is 2, it means that we are also going to have, now that we are done with the how do I call it, um the first part, we are going to also get this part to also connect with this part, and then we're also going to have something like this, also another assembly. So that is how we are going to get, or how our assembly is going to be, right? So this is how you can be able to assemble using parts, using the orthographic projection, just using the clues of dimension, geometry, shape, internal features. You should be able to assemble every part, right? So let's now erase this. Right, so this is something that you can also try on your own. It's just like the first one that we went through. So just try your hands on it and see how well you can be able to assemble this knuckle joint. So the next part would be the theory on how to be able to use AutoCAD to draw this assembly, right?